All right, we're going to look at something called a perfect square trinomial. This comes in really handy when you're trying to complete the square so you can find solutions of a quadratic equation. So first of all, what do I mean by a perfect square trinomial? So this right here is a perfect square because it's a quantity squared. And obviously, if we multiply that out, we get a trinomial. So right here, there are three things added up together. So that's what we call a trinomial. But it factors in this very special way called a perfect square. As another example, x minus 5 quantity squared. That's also a perfect square. It's x minus 5 times itself. So that's kind of a nice form. And when we have it in this form, it's very easy to see solutions of this quadratic. For instance, if this was set equal to 0 when x equals 5, it's very easy to see that's one of the solutions. Or if this was set equal to 0, it's very easy to see that x equals a negative 4 is one of the solutions. So sometimes kind of forcing things to get into this form is a very handy thing to do. Obviously, if we multiply this one out, we'll get another trinomial. So let's first just practice, given an equation, how can we force it into a form of a perfect square trinomial? So that's what we're going to do here in these little exercises. I'm going to give you a trinomial with a variable c, and we're going to figure out what c needs to be to force our equation into this perfect square trinomial form. The rule is very easy. So if I give you something like this, what c needs to be is just b over 2. So let's make sure we understand the form of this equation first. In general, this is always ax squared plus bx plus c. So this value right here has an a of 1, this right here has a value b of 10, and right now our c is a variable c. If I'm trying to force this to have a perfect square form, I can always set c equal to b over 2 quantity squared. So this equation right here in the blue box, that's kind of the key thing for forcing things to have this perfect square form. For this particular example we're working, b is equal to 10, right here, right? b is equal to 10. So if I compute 10 over 2, which is 5, that's 5 squared, I get 25. So if c is 25, this has a nice perfect square trinomial form. In fact, given that value for c, this will actually have the form now x plus 5 squared. And you can kind of see what happens if we multiply this out. We'll get x times x is x squared. Then we'll get a 5x plus a 5x, which is 10x. And then 5 times 5 is 25. So we've kind of forced this to have that perfect square form. Let's do it again. What if I gave you this? Y squared plus 15y plus c. What value do I need to have c be such that this turns into a perfect square trinomial? Well, that's pretty easy. I just figure out what b is. In this case, b is 15. And then I divide it by 2 and square it. So 15 over 2 is 7.5. 7.5 squared is 56.25. So if c is 56.25, then this factors very nicely into the perfect square y plus 7.5. And hopefully you can kind of see what happens. The final thing that we end up with is always this value right here. 15 over 2 is 7.5, so that's why I have a 7.5 there. In this case, 10 over 2 is 5, so that's why I had an x plus 5 right here. Let's go ahead and do one more. What if I had g squared minus 6g plus c? So b is a negative 6. So a negative 6 over 2 squared is what I want c to equal. A negative 6 over 2 is a negative 3. A negative 3 quantity squared is 9. So if c is 9, then this turns into a perfect square trinomial. What number am I going to put? It's going to be this number right here. A negative 6 over 2 is a negative 3. So g minus 3 squared is the perfect square trinomial. All right, so there's a few examples of how we can force quadratic terms to have this perfect square form, and that's very useful when we start working other problems where we need to complete the square. And the key equation is really this equation right here. The amount that we're going to add in, or the amount that we wish c was equal to, is always b over 2 quantity squared.